Hello my friends, today I'll be going over Netcode for game objects. Now Netcode is a Unity provided framework which allows real-time multiplayer, and it is incredibly simple and streamlined to use. So not only am I going to show you how to get up and running with it, I'm also going to explain how each piece works and a few tips to get the best, most performant network code. To begin, we'll be needing a few packages. So go to Windows Package Manager, and we'll be adding 3 different packages here, which I'll put up on the screen as well as in the description. And to add these, just click the plus, add from git-url. First one will be Netcode for game objects. The next one is the, I've actually already got it in the project here, the multiplayer samples utility, but just add by url and put that there. You'll get it from the description. And the last one is just a little helper library, which Unity recommends, which will help us test over multiple clients. Because obviously when you're testing a multiplayer game, you can't just test it with your just your one editor. So previously people would go to File, Build Settings, they'll build their game. And then once they've got their build up on the screen, they'll also press play, and now you've got 2 clients. But that is a horrible way to do it. This is a far better way to do it. So just add the ParrelSync. Cool. To get started with Netcode, just create a new object here. Let's make it a network manager and reset that to 0, even though it doesn't matter. And let's add a network manager. So what the network manager is you can look at it as kind of like an orchestrator of the network game. So all we actually need to touch here is the transport. So a transport layer is just the code which facilitates the initial handshake between you and your peers. It monitors the integrity of the connection to you and your peers. So like if you're dropping packets, it will resubmit the packets. For us, we're going to be using the new Unity transport, which is basically version 2 of the now deprecated Unet transport. So as soon as you click Unity transport, you'll see that it creates a new script here. We don't need to check anything here. So to actually play online, you need a character to control, right? So I've got this little player here. It's just a capture, and it's just got a player controller script and a rigid body. And when I press play, you can see that it can kind of just like slide around a bit and also follow my mouse. So to tell the network manager that we want this to actually be a network object, all we need to do is add a network object to our player script, and we don't need to change anything here. Now, if I just apply those changes to my prefab, then I can just remove it from here. Now, the beautiful thing about Netcode compared to other network frameworks, at least that I've used, is Unity is smart enough to know that in almost every single game, each player has one main player object, right? So they have introduce this concept of a player prefab where we can just drag our player object into that player prefab, and it acts just the same as any other network object that we spawn, but Unity restricts each player to only have one of this specific object. And what this allowed Unity to do is give us like extra functionality specific to the player object. So for example, when we first enter a game, Unity will automatically spawn this player prefab along with some other helper functions, like being able to always have a reference to these player objects without us having to write a whole bunch of reference code. So it's a nice little quality of life improvement that Unity has given us over other network frameworks. And that's actually all we need to do to have a synced object. So to test that, if you download ParrelSync before, just open it up and click Create New Clone. And what this will do is it will actually copy the entire project folder and make a duplicate of it. And once you've cloned your client, you can just open in a new editor. Okay, cool. So I've got my second client here. If we press play on our main client and then go to our network manager, we'll see that we've got these 3 buttons that show up: start host, server, and client. So the server is a computer that is acting as the authority. So depending on how you have things set up, all traffic from the clients will actually route through the server and then back to the clients. That's not always the case. Or for example, if you are having dedicated servers, you're paying for dedicated servers, you would have just like a Linux box up in the cloud somewhere, and that would act as the server, and then everybody would just connect to that. A client is just the actual players in there. Just every single computer connected to the server is going to be a client. And if you're not doing dedicated servers, then one of the clients will also be a server. So you can actually be both. And then start host actually does both for us. So if I click start host here, it will actually fire up a server locally, obviously, and then also connect me as a client. So I'm going to do that, start host. And I'm just going to move myself over here. And then on my other Unity, I'm going to And we can't actually see the buttons because I've I've removed the actual bar here. So I've written this little script here called network buttons, and all this is going to do is just put those buttons on the screen so we can actually click it on the screen. So I'm just gonna slot that right on the network manager. Now if we press play, we'll see that the buttons are here instead. A little bit easier. And as you can see, when you save a scene on your first client, it will propagate over to the next client, which is very, very handy. And I'm going to connect as a client, and now we can see that it has gone on both clients and it's actually syncing. But if I now go to move here on the client, you'll see that we're actually controlling both for one, which is obviously not good, but also the movements are not being shown on this client, right? And that's because, yes, we have made these network objects and the network manager knows that they're network objects, but we're not telling Unity what sort of data to sync. We're not telling them, hey, please watch the position or rotation. We're just not syncing anything at all. So let's fix that first problem of being able to control other people's characters. So let's open up the player controller script. And I'll just go over quickly what this is doing. You don't really need to know, but I'm just handling movement here and rotation. So here I'm just adding some velocity depending on input, which I'm grabbing here. And then I'm also just like staring at the mouse position. So you don't really need to know anything in here, but what we will do is we'll change this mono behavior to a network behavior, which is a Unity provided script, and it also inherits from mono behavior. But this just gives us a whole bunch of useful network functionality, things that we can override and stuff like that. Speaking of, let's override the on network spawn. And then in here, say you jump into a game with 10 people, your player character is actually going to be spawned on all of those 10 computers, right? So this code is actually running, even though that it's your object, this code is executing on all the other computers. We only want to be able to control our local character. So what we can say is if we are not the owner, so owner is a part of this network behavior. If we're not the owner, then let's actually just destroy this script. So that's one problem fixed, but now we need to actually tell Unity how to sync the data, right? Like what data actually needs to be synced. So if you downloaded that second script that I told you at the start, that actually provides us with a few Unity helper functions. So if we go into our player here, the ClientNetworkTransform. So just add that. And as you can see here, we're given a whole bunch of different things that we can actually transmit over the wire. And the name of the game is to always transfer the least amount of data, obviously, right? So for us, I know that we're always at Y0, so we don't need to sync our Y position. I also know that we only rotate on the Y axis, so we can actually turn off X and Z. And I also know that we're not scaling at all, so we can turn that off too. So now this is only going to sync those 3 floats. Cool beans. Now, if we go back here and we start this up as a host, start this up as a client, we'll see that we're only controlling our own, and it's also transmitting our rotation and position. So that was the easy way to do it with the Unity provide client transform script. I'm going to show you how to serialize your own data, which is definitely the recommended way, as it allows you to only transmit the exact data that you need and you have full control over it. So let's stop this and let's make a new script here called player network. And the way that Unity handles network serialization of data is they use a thing called NetworkVariable. Let's do our position. So vector3, and let's just call this net position equals new network position. Now I'm going to get deep into this, but for now, you just need to know that there is 2 different authority types. So there's client authority and server authority. But yeah, we'll get into it a bit later. But for now, I'm just going to set my write permission to owner. So the owner of this object is allowed to update this, this net position. And in the new C# version, we can remove the boilerplate there. And let's duplicate that. And I'm going to transmit a quaternion for now, and we'll call this net rotation. Okay, so here is where it gets interesting. Depending on if you own the object or not, you are going to be either writing to the network variable or reading from the network variable. So what we can do is, well, first we need to inherit from network behavior. Now we're going to check, are we the owner? If we are the owner, then we need to write to this so that everybody else can read it. So we're going to say netPosition.value equals transform.position. And we're going to say our netRotation.value equals transform.rotation. But if we are not the owner of this object, we are now just going to set our variables to that. So we're going to say transform.position equals netPos.value, and our transform rotation is equal to netRotation.value. Easy as that. We are just either writing if we own it or reading if we don't own it. We can actually make these read only. Cool, so now we need to open up our player. We'll remove this Unity script, the ClientNetworkTransform, and we'll add our own one, player network. So now if we start up here and host it, and then we start up this one and client, you'll see that we are in fact syncing our position and rotation, but you'll see that it is a little bit choppy, right? And that's because in the Unity one, which was nice and smooth, they had a whole bunch of interpolation logic. So if you can imagine right now, we are sending our network position like quite frequently, but on the other people's computers, we're basically grabbing that new position and directly setting the transform to it. So obviously there's going to be a whole bunch of frames that we're going to be missing. What you need to do really is just write some interpolation here to make it smooth, which I'll show you shortly. But as we said before, we ticked off a whole bunch of floats in the Unity one, right? And that's because we didn't actually need them. So for example, this vector 3 has 3 floats. We actually only need 2 of the floats, whereas this quaternion has 4 floats, but we actually only need the y of the Euler angle, right? So how can we pack this? How can we pack these bytes as efficiently as possible and with the least amount of data as possible? And that is using your own version of serialization. So I'm going to create a struct here, and let's call this player network data. And in here, we'll keep track of a few things. So private float, and this will be our X position, Z position. And we'll also have another float here, and this will be our Y rotation. Whoop. So Unity still doesn't know how to serialize this properly. So we need to actually tell it, and we can do that by implementing INetworkSerializable. And it will tell us that we need to implement this missing member here. So let's actually tell Unity how to serialize. So we can use the serialize value, and we'll send in a ref, and that will be our X. And we'll just duplicate that line. This one will be our Z. This is our rotation. This will be the rot Y. But as you can see, I've made these private. I don't actually want to modify these directly. So I'm going to create a getter and a setter. And this will be an internal, as I'm just going to be accessing it from within this class here. And this will be a vector3 position. Let's make a getter here. And this will return a new vector3. It will be our X, 0 for the Y, as we know that we're always going to be on 0, and Z. And for our setter, we'll do X equals value.X and Z equals value.Z. So that's our position, and we'll also do the same for our rotation. And I'm going to be using Euler angles. So I'm going to return an Euler angle, and this will be called rotation. Our getter will be new vector3, and it will be 0, and then our Y rot, and then 0. And our setter will be, rot Y equals value.Y. Cool. So instead of having this vector3 and quaternion, we can now just slap in our our network player state, and let's call this net state. So I'm not going to sit here and write it all out. I'm just going to paste it in. So here's the difference. So when we are the owner, we are now just setting the net state to a brand new struct, which is the same details as what we're doing before, right? And when we're reading it, I've added some hillbilly interpolation. So please don't use this in a production game. This is just what I do to do some really quick and dirty interpolation. It works most of the time. Cool bananas. So let's just try that out. So let's host here, and we'll start this one up as a client, and you'll see now that it is nice and smooth. I say that it's hillbilly interpolation, but it actually works really, really well. Hey there, I'm pleased to announce Unity is sponsoring this video to highlight all of the cool services that are moving out of beta and into general availability. With these services, your entire multiplayer backend is handled for you. So for example, you can authenticate your players when they enter the game with any third-party providers. You can save their progress, like their inventory and their stats. You can manage your game's currency and item set with economy, and you can call sensitive server-side code with cloud code. And let's not forget lobby and relay, which will allow you to set up global matchmaking for your game. I'll put some resources down in the description if any of these piqued your interest and you want to get started learning. Back to the video. Now, looking at this code, is there any way that we could make it even more efficient? Can we transfer even less data across the wire? And I think yes. So right now we're sending a float across for our Y rotation. Do we really need the accuracy of a float? So like 360 degrees, do we really need 360.1? I don't think so. So what we could do here is we could change this to a short. And then here, all we need to do is convert this to a short. So now we're going to be sending less data at the expense of a tiny bit of accuracy. And I've just looked in the mirror and noticed that my headband has been like slowly. The reason I'm wearing the headband is because my hair is ridiculous because I'm trying to grow my hair. It's super messy. And I like wearing hats, stupid hats in my videos. Okay, so to save some time, I have gone and written a few example scripts, and I've also updated and improved the player network script, just so I can show you the difference between server authority and client authority. So I've got this little Boolean here, which toggles it. And depending on if it's true or not, it will say, all right, this can only be written to by the server or the owner. And I'll just quickly go over the other changes. So in update, if we're the owner, we're transmitting the data. So kind of the same thing. And if we're not the owner, then we're just reading the data. So there's my hillbilly interpolation here. If server authority is false and we're just client authority, and I'm just going to remove this to make it a little bit simpler here. So if we are not server authority, then we can just write our value, right? But if server authority has been turned on, that means this client cannot actually write this. It will throw an error saying client is not allowed to write to this variable. We actually have to tell the server, hey, this is my new state. Can you please propagate this to the rest of the clients? And we do that by calling a ServerRPC. Now, RPC stands for Remote Procedure Call. And basically what it is code that you can execute on another system. So what this is saying is, hey, here's my state. Server, when this actually runs on the server, please update my player state, because as I said before, the server is the only thing that's allowed to update this now if server auth is turned on. And let me just put this back again. So I just removed that because it was a little bit confusing, but obviously even if server auth is turned on, if this client that is actually running this code is the server, obviously we don't need to do this server RPC. We can just like directly write to it as well. But it does show you that if you have a game of 10 people and one of those people is the server, that person obviously has a slight advantage, right? He or she will be able to execute this immediately, whereas all the other clients have to it has to be propagated to them, and there's going to be a slight bit of lag. So if this is like shooting a bullet or something, obviously the server now has an advantage. So just to go a little bit deeper in server versus client authority, with client authority, it's actually a lot easier to hack because someone can just make a client hack and say that they just shot 100 bullets in 1 second, or they're running 3 times faster than what everybody else is running, right? Because there's nothing there to check it, because we're just trusting the client that whatever they say is gospel. But at the same time, it also provides a better user experience because everything is really reactive to the client, because everything they're doing is immediately firing for them, right? Whereas server authority, it's harder to hack because whenever you shoot, this information has to go to the server can check it and then propagate it to all the clients. So it's much harder to hack, but obviously now there's that network loop, so it's a bit laggier, doesn't feel as good. But saying that, you don't need to do everything server or everything client. You can actually make a mix, and there's a few tricks that I'm going to show you that allow you to use server, but also give the local client still a good user experience. Okay, so let's actually start with the player shooting. And this script will actually teach you a lot. So yet again, we've got our ServerRPC, and if you remember what that is, it is server code that can only run on the server but is triggered by clients. And then we've also got a ClientRPC here. So a ClientRPC is can only be called on the server, but the code within is executed on all the clients. So it's kind of like the opposite of ServerRPC, and it will all make sense in a moment. So what are we doing here? We are, when the player presses the left mouse button, we will send a request to the server to say, hey, I just pressed the left mouse button. Can you please spawn a ball or a projectile from my character? So that will go to the server. And as I said, ClientRPC can only be called from the server. So the server will now call ClientRPC. So then from all the clients, we'll now call execute shoot. And if you'll notice here, this is actually not a network object. I'm just spawning a local version of this projectile on everybody's client. Everybody might receive this with a few milliseconds difference, but it will still spawn in the same position with the same direction, and kind of like everyone's just managing their own version of it. So it kind of just showcases that you don't need everything to be a network object. You can save some bandwidth. So let's test this out. And because I'm on a LAN right now, there's not going to be any lag. So what I'm going to do is I'm going to go to my network buttons, which I know is just attached to my network manager here. And I'm just going to add this little snippet here. So basically what we're doing is we're setting some debug simulator parameters. It's just like adding some artificial lag to our network so that we can like efficiently test, right? Which is pretty awesome. And also at the bottom of this script here, whenever I press fire, I'm just gonna toggle this indicator and it's just gonna show a label on the screen for a split second so that you can see when I actually click, and then when the actual ball is spawned. Okay, so on my prefab, I have attached the player shooting script and all the references that it needs. And now let's start up a host here and then start up a client here. And watch the top left screen here. You'll see when I click and when the ball is actually spawned. As you can see, there's a bit of lag there. Now, as you can imagine, that would feel absolutely horrible for the user. And if we pop over now to the server, you'll see that it's instant. That is the server advantage that I was talking about. Let me show you how to fix this problem to make it seem nice and reactive for the local players. We'll still send off the ServerRPC, but for us locally, let's actually execute our projectile. Let's actually shoot it straight away locally. And then when this ServerRPC actually propagates to all the clients, we can say, well, if we're the owner, we actually don't want to shoot that, do we? Because we've already shot our own local version. So this request is still going through the server to all the clients, but for us, it feels nice and reactive. So now if we go back to here, we start up a host and we start up our client, we'll see now that it is, the second I press it, it is shooting. Beautiful. One final little lesson that I would like to show. I've got this player visual script. So the purpose of this script is to change the player's color when they enter so that we're all a little bit more unique. So by default, these network variables are only changeable by the server. So we will need to send an RPC out for the server to change it, obviously, but I'm doing it a little bit differently here. So I'm not checking this net color in an update loop. I'm actually subscribing to its on change event, which means obviously it's a little bit more efficient. We're not checking it every single update. And then on our change event, we're actually changing the color of the renderer. So here, how it works is on network spawn, we're just grabbing our owner client ID. So this starts at 0 for the first person that enters and then it gradually climbs. We're getting this from the network behavior. And we're grabbing a color, get next color. It's just grabbing it from this list here and then sending this RPC to the server to say, hey, can you please change my color? And then when that actually happens, obviously this is going to trigger and we're going to change the value. But the reason I wanted to show you this is one very common gotcha. So here, this starts up and I'm the owner. So I've selected a color and then sent this to the server to select my color. But if I was to do this right here, renderer.material.color equals netColor.value, this value is not going to be what we have requested it to be because this is not instant. This queues up on the server and then is eventually run and then propagated to all the clients. So this would actually set to like some default color, which is black. So we've got this on trigger enter. So when it goes into the trigger, it's also going to like send another request to change. And this thing right here is what I've set up as the trigger. So let's start this up as client. Now as the server, if I run through this, instant color change, obviously, because I'm the server, we're just sending a server RPC to myself. But as a client, you see that there's a bit of a lag. So this would be another thing that, just the same as the shooting, we could like immediately do for our local player, and then everybody else will get like a little bit of a lagged update. But yeah, just another example of the difference between server and client authority. So as of right now, this multiplayer game is actually only available to play over LAN. In the next episode, I'm going to introduce you to Unity's lobby and relay system, which will allow you to set up global matchmaking. So any person that opens up your game anywhere in the world will see any open lobbies that people have made and can just click on one and then get straight into the game without knowing each other's IP or anything like that. So stay tuned for that. That will be out very soon. And all the code from this tutorial will be down below. So have a browse, enjoy, and I'll see you next time. Bye.